In every science fiction story, the biggest hurdle to surviving on Mars is keeping humans breathing. And yes, making sure astronauts have enough oxygen for their lungs is an absolute necessity. But keeping a crew of 4 breathing is actually the easiest part of the oxygen problem. The real hidden cost of deep space flight is the return trip. Getting people off the Martian surface and back to Earth requires massive amounts of thrust, and you cannot get that explosive thrust without combustion. Oxygen is required to burn rocket fuel. Because it serves as a strict mechanical necessity for our engines, it acts as the ultimate transportation bottleneck. To launch a standard pickup truck-sized ascent vehicle carrying a crew of 4 off the red planet, you need about 7 tons of raw rocket fuel. To actually burn that fuel, you need a staggering combustion ratio, requiring roughly 25 tons of liquid oxygen. To picture that weight, imagine taking a normal pickup truck and stacking it with standard 5-gallon water cooler jugs. You would need over 1,300 of those jugs piled tens of feet high to equal the mass of the oxygen required. Attempting to carry that payload all the way from Earth triggers a vicious mathematical cycle. Every extra pound of oxygen packed for the trip forces engineers to add exponentially more fuel to the heavy lift rocket just to escape our own gravity. Packing an extra 25 tons of liquid oxygen makes the initial launch vehicles so massive and so expensive that it becomes impossible to ever leave the launch pad. A crewed mission to Mars is entirely out of reach until we completely eliminate liquid oxygen from our outbound payload. Aerospace engineers solve this by adopting a strategy called living off the land. If we cannot bring our heaviest resource with us, we have to manufacture it on site. To test this, NASA sent an experimental, toaster-sized gold box named MOXIE aboard the Perseverance rover. It serves as a technological proof of concept for alien manufacturing. The Martian atmosphere is harsh. It is 100 times thinner than Earth's, but it is incredibly rich in carbon dioxide. A carbon dioxide molecule has 1 carbon atom bound to 2 oxygen atoms. MOXIE uses extreme heat to fracture the molecule, snapping off a single oxygen atom. That isolated oxygen pairs with another to form O2, transforming a toxic atmosphere into pure rocket propellant. Successfully splitting these molecular bonds requires the interior of the oxygen generator to reach extreme, blindingly hot temperatures. The current version of MOXIE produces a tiny trickle of air, which is a long way from the 25 massive tons required for a human return flight. NASA's actual mission architecture involves sending a vastly scaled-up, industrial-sized iteration of this exact oxygen generator to Mars years before any humans leave Earth. Operating completely autonomously, this robotic factory will spend months or even years slowly harvesting the atmosphere and filling up an empty rocket's fuel tanks. This creates an ultimate fail-safe protocol. No astronaut will ever strap in for launch until sensors confirm that the Martian gas station is already full and waiting for them. During the Apollo missions, the astronauts operated essentially as tourists. They had to pack every single ounce of their air, food, and fuel inside a closed loop, hauling it all the way from home. That strategy works well for a brief trip to the moon, but it completely breaks down when stretched across the multi-year distances of deep space. Long-term survival requires a pioneer model. Instead of insulating ourselves against the alien environment, we have to actively integrate with it and use what it offers. An autonomous oxygen generator acts as the solar system's first true piece of extraterrestrial infrastructure. It provides the literal breath for our lungs, while simultaneously manufacturing the explosive fire needed for our engines. True cosmic exploration begins the moment we possess the technology to turn a dead, hostile world into the exact mechanism that brings us safely home.